This video will cover the topic of silyl ethers. Remember that our common ether contains two bonds between carbon and oxygen. A silyl ether has one bond from the oxygen to carbon, and the other bond is from oxygen to silicon. Silicon is just below carbon in the periodic table. Therefore, it also forms four bonds. And in a silyl ether, those four bonds are also to carbon. This is the general structure of a silyl ether. Silyl ethers are more easily formed and more easily cleaved than regular ethers. Because of this, they make good protecting groups. A protecting group is a reversible chemical modification of a functional group that prevents it from undergoing unwanted reactions in a chemical synthesis. Let's look at an example. Say you want to carry out this transformation. The transformation that is occurring here is from the Grignard addition to the ketone. Of course, you can't carry out a Grignard reaction in the presence of a free alcohol. Therefore, we need to protect the alcohol to prevent it from reacting with the Grignard, so that the Grignard will only react with the ketone as we want. We can protect the alcohol by converting it to a silyl ether before we carry out the Grignard reaction. Let's look at what this will look like. In the first step of our synthesis, we will add the protecting group to the alcohol. Once the alcohol has been protected, we can now carry out our Grignard reaction. In the final step of the synthesis, we will remove the protecting group to obtain the molecule. Formation of the silyl ether is carried out using the silyl chloride and a good non-nucleophilic base like triethylamine. The silyl ether protecting group is removed using fluoride ion in water. The conditions that are used to add the silyl ether and remove the silyl ether are fairly mild, meaning that they don't tend to affect other types of functional groups. This is an important feature of protecting groups, that they don't affect other functional groups that might be present in the molecule.